Hello guys, welcome back to my channel, and today I'm presenting you with yet another important series in mathematical modeling and computational mathematics. So today we are going to discuss a very basic topic, but again this topic can be used and utilized to further build up your skills and cover more advanced topics like gradient descents and other further optimization techniques. So today we are going to implement Newton Raphson method in Python from scratch. So you might have like touched Newton Raphson method in your class and even your university classes. So we are going to implement that method in Python. So you all know that Newton Raphson method is an iterative numerical technique used to find the roots of smooth and continuous functions. We give it an initial guess, then it refines the search by using the derivative of the function, and then the method converges quickly if we don't see any further change in the x value on which the function depends. So this is like one application, but the most important application of Newton Raphson method is optimization. In optimization, instead of like finding the roots of a function, we find the minimum or maximum of a function. We all know that if you have like studied the calculus, we all know that a function might have like a global minimum or global maximum, so at a specific value. So by considering the derivative of gradient of the function, we seek to find iteratively the optimal solution. We find the maximum and minimum of the scalar function, like if we have the function is depends on only a single variable like x, or vector value function, or the function that depends on multiple values like x, y, z. So this is a brief description of Newton Raphson method. So let's get started with the programming. So as you know, the first step in every programming script is to actually import our libraries. In our case, we are going to use NumPy library. So we will import NumPy as NP in this line of code. And once we have done that, okay, so we have done imported our library. So if you have any idea of Newton Raphson method, now you know that we actually need to define equations based on which we will perform Newton Raphson methods. So one way to actually define your equation is to define it in a function. So that's what we have actually done here. So we have defined a function whose name is f here, and it takes the input argument x value on which the functions depend. And our function in our case is actually x squared minus 2. So this is our function here. So we have like x power 2 minus 1 is the function. So this is our function. This is a function, but you want to take it as a equation on which we want to find the square roots of that equation. So this is the equation here. The next thing we need in Newton Raphson method is actually to find the derivative of the function. So using basic calculus, we all know that if we take the derivative of this equation, x squared minus 2, we will get 2x. So the derivative, in our case we termed it as f prime, is 2x. So this is the derivative equation here, which we define in a function. So now we have actually defined our important libraries NumPy. We have also defined our equation, and we have also defined the derivative of that equation. Now let's move on to actually creating the algorithm that will help us actually calculate the root of the square equation using Newton Raphson method. So for that purpose, we are going to create a specific function that is named as myNewton, and we will be passing 4 arguments to that function. The first one is actually the equation, which is denoted by f. The second one is actually the derivative of that function or equation, which is denoted by df. The third one is actually the initial guess. So Newton Raphson method actually do need a guess, an initial value that you might think, okay, this equation might have root value that is close to 1.2 or 1.3. So we will provide Newton Raphson method with some initial guess value of the variable. Then we have a tolerance. Okay, so the idea of tolerance is actually you can take it from the actual value or estimated value, and also what is the difference between the actual value and the calculated value. and I will discuss that in more detail while explaining the algorithm here. So this is the algorithm that help us estimate the value of root of equation using Newton Raphson method. So before like actually defining like the if statement, then else statement, then while true, let me just directly go here and give you the main equation of Newton Raphson method. The Newton Raphson method is based on updating the variable value with the help of this formula here. So basically, let's say you have like initially guessed value of x variable, that is like 1.3, 1.2. Like here we have like 1.3. And what we'll do, like we have this initial guess, then this initial guess gets subtracted from the function or equation value that has been evaluated that initial guess, and then this is divided by the equation or the derivative of the function at the specific value. In our case we will pass x old. So this is like the main equation of Newton Raphson method, and the same thing that I have defined here is used in this line here. So this x1 is actually the updated one or updated variable for that equation. X naught is the initial value or the old value. Here f is actually the function or equation, and df is actually the derivative of that function or the derivative of the equation. So this is the main equations. And now let's discuss more about tolerance. Okay, so at every iteration the value of x gets updated, and to such an extent that it will try to reach the close to very close to the actual value of root of that equation. And as it approaches to the actual value, the difference between the estimated value and the actual value will get reduced. Okay, and that will also be the convergence criteria of Newton Raphson method. We say that as the x gets updated, there's the change in the previous x value and the change in the actual x value or the updated x value should be less than a specific value. If that specific value is quite low or quite less than 0, it means that the value is not changing with each iteration, and we say that Newton Raphson method has been converged. So this is the idea behind tolerance. So the lower the value you will give, the better results you will get. So in our case you see that we have using x old. In our case the x1 is actually the new value, sorry, x1 is the new value, then it gets subtracted from that x naught, which is the old value, and we are comparing it with the tolerance. Like we want to know if this value is actually less than tolerance or greater than tolerance. Okay, so this is the idea of tolerance here. So now you understand the idea of tolerance, and you all now understand the idea of Newton Raphson method equation. Let's go and discuss this code of block here. So first we have defined an if statement, and we are calculating f, which is the equation here, main equation here, and we are evaluating at initial guess value. Okay, like x naught. We will pass x naught, the initial guess value, to that function, and it will calculate the value of that function. For example, let's say we have like 2. So 2 square is 4 minus 2 is equal to 2. So it will return 2. So we say that if this function evaluated at specific value is less than tolerance, then we say that the initial guess is actually the root of the equation. And the idea of this logic is here that the root of the equation will satisfy the equation, that is it will be equal to 0. So in our case we say that the initial guess is actually quite close to the actual value. But if that's not the case, then we have to actually execute the Newton Raphson method, and for this purpose we are going towards else. Like if this statement is false, then the else code block, whatever the code block that is present in else statement, will get executed. Now once we reach that else statement, you can see that I'm using while true. Like I'm telling, I'm using a while conditional statement, and I'm setting it to true, that this like whatever the presence that is present in that while block will be executed again and again. So to get an idea, you say that we have some initial guess value. In our case, let's say this initial guess is 1.4 and we have tolerance of 1 point exponential 6. Okay, and we know that x naught, the value of x naught, and then what it will do, it will subtract the value of function that is evaluated at this specific value, and it then divides the derivative of that functions evaluated at that initial value. Then it will calculate this value here, and a new value of x1 will be get updated into x1 here. Once we have done that, now we want to check that the difference between the updated x value and the initial guess value is less than tolerance. If that's the case, I mean, for example, let's say that is less than tolerance or less than 1 point exponential 6, we say that the conversion criteria is met, and we will return the updated value here. Okay, and if that's not the true, then this statement will not get executed, and then we will update the old x naught with the new x. And then once we have done that, like when we have updated the x value, then this block of code will run again, and then it will calculate again. This value is calculated, and again the tolerance will be evaluated, and it will keep on running again and again until this statement is getting true. Once that statement is getting true, it will return x1, which is the finally converged and is very close to the actual root of that equation. It will keep on iterating this thing until this criteria is met, until this condition is true. Once that condition is true, what it will do, it will return this value which is quite close to the actual value out of that function here. And you can see then assign it to the whatever the variable you have declared here. In our case, it's like estimated root. So just to give you a final idea, we will pass the initial guess. It will evaluate the function at initial guess, checks that if that checks that if the function evaluated is quite close to 0. If that's true, then it will return the value. Function will return the value to the estimated root. And if that's not true, it will iterate using while true condition statement, and it will keep on updating the values, and then it will keep on checking the tolerance, like the difference between updated and old x new, till this condition is true. And once the condition is true, it will return this updated value back to the function output here. And finally, once we have calculated our estimated root, we can actually use simple notations of print to actually print the values, but also see is this value is quite close to the actual value. In our equation, the actual values was square root of 2. So we see that actually they are quite close to it. So that's it for now, and in the future tutorials I will be keeping updating you more about computational mathematics, and more about optimization techniques, and more about using those optimization techniques to discuss further about neural networks and machine learning algorithms. Thank you for joining. I will soon catch you in the next tutorial.